Hello, everyone. I'm glad that you decided to come, even considering the name of the talk. There will be no real cleaning, no brooms or mop or whatever. Don't worry. It'll be a little more fun than that. So I'm LP, Louis-Philippe. I work at Folks Montreal as a co-head of CG and also CG supervisor. And Folks is part of the Fuse group along with FuseFX, Rising Sun Pictures, and El Ranchito. So the talk today is not necessarily directly related to work that we've done at the studio, but more based on our experience with essentially PDG and USD. What will we be talking about is this bar scene. So this was made by SideFX and their marketing team almost 3 years ago. And it was released so in 2019, and we have about 2 gigs of elements in there for a demo USD scene. And the marketing team reached out to me and asked if we could update the scene and see how it could reflect more what we would have in a studio environment, the way we build the different assets, the way we build the environment scene, and just to provide a updated version of that demo environment, but still with the same source material. So we will be looking at the same models. It's the same, same points and vertices and everything, and the same textures. It's just repackaged, rebundled in a probably cleaner way, hopefully. The intent was to overhaul the existing scene, so we would look at every piece, examine if it needed some repair or update, and then we only decided to update what was needed. The next step also would be to create documentation and tutorials and also create workshops. So this is the first workshop, but the end goal is really to have a written tutorial and make the files available to you eventually. So we're not there yet, but we just wanted to show a work in progress of where we're at with this scene. So when I first looked at those elements, so I remember looking at the scene 2 or 3 years ago, and at the time, I think most of us that were not in larger studios didn't have any experience with USD, and Solaris was still brand new to me, so I didn't know if it was built to a certain standard or a certain to a certain quality that is common to many studios. So when I looked at the elements, I saw a lot of good things, but other that were not really in line with what we were doing at Folks, at least. So I decided to split the different steps that I'm going to show you today into three categories. The first one will be about standardizing the files on disk. So this is not necessarily related to USD, but it was just a fun way to leverage PDG. I love the tops. Whenever I can, I try to insert some PDG in my workflows. And I just want to show you a few task operators that can be really helpful when you download a collection of assets from a website or a kit or something, and you want to sort of standardize them without going through your pipeline team, but you just want to normalize or standardize the elements yourself. So we'll go through a few operators. Then we'll look at the build or the asset structure. And I think this is really the core of what the marketing team at SideFX were asking from me, how we should build our USD asset. And I'm sure that every studio has a different way of doing it, but this is very much inspired by the component builder that was released, I think, with 18. And I discussed with the original author of the component builder and how we could hack it to make it more similar to the way we were using it at Folks, and hopefully it's similar to other studios. And then the last part is about assembling the environment, and we'll have a few other tricks here that really work well with the component builder. So first step, standardizing the files and disks. So I wonder if any of you already saw that scene or played with that scene. It's OBJ files as a source for the models. what I decided to do is just look at everything, and that's just a few things I noticed, like the OBJ files were in this directory called base geo, and then the assets were in another directory called library, and chances are that at your studio, no matter the file format, if OBJ, Alembic, or USD, your files will be under a asset directory or for that specific asset, and you wouldn't have a root directory that is the format and then down the structure another for the asset. So I just decided to take those elements and move them somewhere else. And for the naming conventions, I've noticed some things like the use of underscores and tokens. If we look at the first element here, it's called the bar double lamp. Having the underscore in the snake casing like this makes it hard to, when you add other elements in the name, if you look at the texture at the bottom, we can see like bar double lamp and then brown 1001 base color. So because of the snake casing of the name of the asset, it's hard to use underscores down the road to parse the information. And with task operators, so in PDG, like attribute from string, it's really useful to have those really separated. So I decided to go with camel casing and a few things like that. So I'll be able to show you with PDG how to achieve that. All the files were versionless, so that's just something I wanted to add. And there were no concept of asset types. You might not be using asset types, but if you're using ShotGrid, that's how it's structured. So I decided to add that as well. So on the left, we would have original files, and on the right, what I ended up having. And all of that was made with, again, PDG. So from snake case to camel case, I decided to change all the naming that were either, for small, sometimes it was just S or SM, sometimes it was uppercase, lowercase, so just standardizing all of that. And I was able to do it with a few operators. Yeah, here. So first thing I did when I wanted to look at the models is using this file pattern top. So file pattern used to be called file glob, I think. But it's really interesting that you can use wildcards. So you put down a path, then use wildcards and an extension, and then it looks at all the files with that extension in a given directory. So that way I was able to find 67 assets. And with a setup like this here, the first image on the left, the file here has an expression called PDG output, and it takes the output from the PDG graph, and it loads in the path as in your subcontext. So along with a font operator, I was able to create this sort of inspector or debugging tool, and I was able to figure that some assets were exported at the center of the world, but other were just exported wherever they were modeled or placed before export. So I knew I had some standardizing on this side as well. We can see in the middle image here the font, the font sup, so surface operator. So this is in the geo context, as you can see in the left image. When you use the ticks and the at syntax, so it's the HScript syntax, you're able to get those attributes from the different work items. So what we're looking at here, all the dots in the file pattern nodes are work items. So basically in this case, because it's the file pattern, it is a file on disk. It was an OBJ file. So whenever I click on a new work item, it loads or it computes the graph, in this case, only one node. It returns some attributes. Here we can see on the right the attributes. I got like the file name, the directory, and a few other things. And I can use those attributes in the font operator to generate the text that we were seeing here. So in this example, it's only the name of the asset. But if I join, for example, the directory and the extension, I could get the full path here displayed in my scene. So that's often something I would do, especially with kits. I want to download everything and just see the model and see how it's named. And it's very easy with the file pattern top. Then I this is the final top or the final PDG graph that I ended up creating. And there are different steps. You can see the titles at the top. So the first two longer columns, that's for taking all the OBJ files, finding the different attributes that I needed, renaming those files as I was doing from snake case to camel case, and then moving the files somewhere else on the network. So the left one was for the OBJ and the right one is for the textures. What I like doing when working with PDG like that is to start with a first operator, an attribute create. An attribute create lets you create a float, an array, a string attribute on the work items. But I start with a single work item pointing to a directory. So it'll be my root directory. That way, if I decide to, in this case, I was working with the original data from the SideFX bar scene. So I would have a first copy I would download, and then I would try some things. And with PDG, you're actually moving the files and renaming the files, and sometimes you mess up. So you might have deleted something that you didn't want to. So I would unarchive the scene again under another name, and I would change the root directory that way. So a little bit like you would use $hip or $job, I was able to have a working directory with that root attribute that I created. And I tend to start most of my PDG setup like this with a single work item pointing to a root directory. What's nice with PDG is that you have a visual scripting language, or you can organize tasks visually, but there are some things that you might want to use Python for. And when I started using Python in PDG, I was sort of confused because there was this Python script, Python processor, Python partitioner, and I think there's like Python command chain and other Python operators. Most of the time, I would say I end up using Python script. Python script and Python processor are kind of similar. In the examples that are provided with the Python operators, a little bit like when you're using the attribute wrangle, there's this, on the right side of the text editor, there's this arrow that you can use to load in preset snippets. Here you have the same thing for the Python script. For Python script, it's mostly about the work items or creating new attributes, things like that. For the Python processor, it's more about generating new work items, or it's a little wider. And then for partitioners, to create groups, just as the attribute partitioner would do, or other partitioner operators. So I ended up using the Python script a lot. For example, from all those OBJ files that I found on disk, I wanted to eventually create, I'll show it to you in another slide, but I wanted to create a LUP network for each asset. So creating a new node in Houdini, I used Python to create new nodes based on what I found on disk. CSV input and output, you could use JSON or other file formats, but at some point I needed to accept one thing, that I couldn't do everything procedurally, and that's always something quite sad. I just want to give you an example here. That's just a part of the list of all the assets, and there were so many exceptions. Like as I was saying, L and S, I wanted to call them large and small, and the camel casing and everything. And just because there were so many exceptions, and I was starting to branch out my top graph a lot, I just decided, let's write down everything to a CSV file. I'll do the changes manually and read back the CSV instead. I got defeated. But it's fine. At some point, you need to accept that it won't be done procedurally all the way through. But I thought it was a good compromise just to get things going. And what's nice here is that you can export the result of all the work items that you have. So I know I'm jumping back and forth in my presentation, but I just want to come back to this here. So all the work items, those little green dots in the file pattern node, they all have a list of attributes. So if you want, you could export a CSV file or a JSON file with, in this case, 75 rows, and all the columns are the attributes that you want to export. Here we can see a few attributes, but when exporting to CSV, you can select what attributes you're exporting, and then you can also decide if you want a header to that CSV file. So that's what I ended up doing. I wrote down to disk and read it back. Here, those are very, very nice. So you got other operators to copy files, rename them, remove them. Another one that I've not used here is make directory, and they are very similar to Unix commands. So if you use the terminal in a Linux workstation, you can do something like cp, and it will copy. You would get you would point to a file and then where you want to copy it. Same thing with rename, which is basically moving a file. But all of those are now accessible to you with those operators. And I was not really someone really into terminal commands in Linux, and just getting to understand how it was working with the tubs, I ended up being able to use a terminal a little more. So I think it's interesting that PDG gives you the knowledge without sometimes the terminal scared me. I didn't want to mess up things, but now you have a visual feedback of what you're doing. And especially with file remove, you can run it, you can do a dry run. So it will only say, okay, I found the file that you want to delete, but I've not deleted it. But then you can uncheck that dry run, and next time you run it, it really deletes it. Quite useful when you just want to make sure that you point it to the right file, because the path that you end up giving to that remove operator might be multiple attributes that you concatenated together, and you don't want to have messed up something and deleted something that you didn't want. And another very interesting thing is that, for example, the make directory, I use it a lot when, or the first time I used it was to create a file structure for a project, a personal project I was doing at home. And because I had multiple, I wanted to create a structure with different, applications or different shot name, sequence name, and things like this. I ended up having a lot of work items with similar attributes that would end up creating the same directory on disk. But PDG is smart enough to understand that a task was already done. So if the output of two tasks is the same, the second or any other instance of that task or any other task that would have the same output won't be processed again. Basically, it means that if you already created that directory, it won't create it, it won't override, it won't create a new directory. So even if you end up having 2,000 work items and you press start and you compute everything, but at the end, it's only supposed to generate 100 directories, you'll only get those, and the other 1,900 tasks will just be skipped because PDG understood that those were already made. Quite neat. And the other operator I used for the first time on this project was the generator. And again, it's basically just a terminal. So you could use any utility tool that you want. In this case, I decided to use iMakeTX, which is a utility package with Houdini, and it lets you create mip-map textures. All the textures that were coming with the scenes were not mip-map, so I just decided to run them through this. You could probably use any mip-map manager that comes with your render engine or anything, but we got PDG. And I think we often forget about all those utilities that come packaged with Houdini, so it was just nice. Look up at the documentation. Here I have a small screenshot from the documentation, but there are, I don't know how many, but probably more than 30 utilities that come with Houdini. You end up creating your command like this, and you run it as you would do in a terminal. So at Folks, we use res to resolve our environment. So here, I resolve the environment for Houdini, giving me access to that utility. And then the double dash lets me create or run two commands one after another. And here, I make TX, the path to the original texture file, and then the path to where I want to save the new image, the mip-map image. I decided to use the RAT file extension, but I could have kept EXR. It was just, for me, easier to see what was the old one and what was the new one, but I could have kept EXR. So those are some examples of things I needed to do to clean up all the files on disk with PDG. And I don't know how long it took to set up the whole thing, but to run the graph takes a few seconds, and at the end of the day, you get all of those reorganized. Another thing I did was to convert the files to USD, and this is really where I think it gets interesting. So for anyone with experience with USD, it's not because you're using USD as a file format that it's necessarily following the idea behind Houdini, or sorry, behind USD. So 2 days ago, I think it was at DJ Pro, the talk by Animal Logic, they were saying that you could use USD as a file format, you could use USD as a description of an asset, but you can also use it as a way to compose a scene. So you would end up having multiple layers, and then the result of the asset is the composition of all those layers. And what's really nice is that the work that was done for the component builder really steer you in the right direction. So previously in the scene, most or all assets were groups. A group is a kind, so any primitive in the graph. So if you look at all of those lines here, all the elements here are primitives, and the root primitive was a group. When we're talking about an asset, it's usually a component, and you would have in a group multiple components that might be depending on how you want to work, but the way we work at Folks is that a group would be a sort of collection of multiple components that are sharing the same space. For example, here on the stage, I could have an assembly for the whole room here, and then a group for the stage, and another group for the table and what's on the table, and then my computer or the mouse would be different components. You can have as many layers of groups and assemblies as you wish. But usually the asset itself would be a component. Then if you decide to use subcomponent, that's maybe a little more up to you. In this example, I've not used subcomponents, but at Folks, we tend to use them. So that was the main thing I wanted to change, was to have those being components instead of groups. Then there was no proxy or guide purposes. So a purpose lets you have multiple, I don't want to say version, but multiple, let's say version. Multiple version of the same asset, one meant for rendering, the other one to display in the viewport. So in our PDG setup, that will be eventually available when we release the scenes, you'll be able to see that there's some cleaning up. As I was saying, some assets were not modeled at the center of the world. So with a match size, for example, I was able to bring everything at the center, and I did a bunch of, resetting the normals, cleaning up some floating points, and fusing some points that were not necessarily fused or things like that. But at the same time, I ran a poly-reduce. That's simple. I ran a poly-reduce and saved another version or another purpose for the asset. So I would have the render and the proxy purpose for every asset. So that way, when you load the scene, you'd be able to have a lower resolution version of all the assets. When we look at the root prim, or here, for example, the geom here, it's a XForm primitive. So XForm means transform. It means that you can move the primitive in space. What's interesting with the component builder is that, for example, the geo, the proxy, and the render are all under scopes. Scopes are still primitives that let you organize your scene graph, but you cannot move them. So here the transforms are all saved on the root, which is the component itself. But it means that you can't, by accident, have the proxy and the render purpose moved in different directions. So you would never have something that looks good in, not never, but you should have the same asset, or the asset has the same position in the viewport and in the render. And if we look here, there's only one purpose, but just the way it was saved, it could happen. So that's why using scopes is very, very important. Another thing, it was not leveraging classes, and I was not using classes until the author of the component builder explained them to me, and those are very powerful. So a class here, to me, it was just an extra primitive, and it looked clunky, or I didn't know what to do with that. But once you have a class for every asset or every component, when you load in the asset later on, the class won't show up, but you'll be able to right-click on any copy or any reference of the component in your scene, and then edit not only the reference, but the class. So you could, for example, change a shader for all the references of an asset, or you could change. Here you can see this is the bar double lamp, and I've included the light primitive in the component. So that way, whenever we bring in the lamp, we have their lights with them. So we have a light rig. I could decide to change the color of the lamp because, I don't know, in the shot I decided that the light temperature was a little off. But since now I have a class, and it's important that the asset is exported with that class from the component builder. You can create the class without the component builder, but it's just there for free. It means that if you want to edit any part of the component and what's inside, you can apply the same changes to all the references in your scene. Very, very powerful. And yeah, as I was saying, there were no lights included in the asset, and I think it's a good practice to have those as a separate layer, but still inside the component. And finally, here the materials were under scope. I think it makes sense. You can't really move materials in space, so those were perfect as they were, and we have the same structure here. There are things that I think we could improve from the structure I'm suggesting here today. The way we payload our reference elements could be different, and I think we could add a xform primitive between the render scope and the meshes. That's really up to how you modeled in whatever DCC you decided to use. But there are some things that might be refined before we get those scenes available for you. Then the component builder here, you can see it's a suite of nodes. It starts with the component geometry, and then you have component material, I think, and component output. Even if you don't want to use all the features here, for example, if you look at the component geometry, it lets you either use the internal subgraph to use an OBJ or whatever, use any kind of data, bring it into a sub-context, and then there would be three outputs, one for each purpose. So one for render, one for proxy, one for guide. But the way I decided to clean up the data with PDG, from the PDG graph, I already exported the USD asset, and the component builder, the USD asset, or sorry, the USD model just as a file format, but there would be no authoring of purposes, kinds, or anything like that. So it was just, a geometry without anything else. It's just that instead of saving another OBJ or another Alembic, I just wanted to go full USD, and that first step would be just a pure geometry. But I wanted to use the component builder to build a hierarchy, have all the layers, and eventually compose a stage for my asset. But the node couldn't let me do that exactly. So that's why here I decided to use references instead to load in the USD geometry. But it was important for me to use the other nodes around just to create all the goodness that the component builder allows. And finally, here, assembling the environment. As I was saying earlier, the way the scene was packaged was hard for me to understand what was an asset and what was just there for organization of the scene, because everything was a group. But now it's a little clearer what is what, so we can see that components here are the different asset. Groups are, as I was saying, a sort of collection or a group of elements together. I really encourage you to use the asset reference. So it lets you reference in an asset, but you can also author the variants and place the element in your scene. So very, very useful. Another thing I think is underused is the fetch operator. So it acts very much like a object merge in SUP. It lets you take the output of another node in the graph and just brings it here. It just helps keep things tidy. And graph branches was what I decided to use to organize things together within groups. I could have used a restructure graph, but it was just a little easier for me with the graph branches, because the new root primitive I would give to this, all those bar shelf appliance large components was already set to group, and it was not just a blank X form. So I was able to do what I wanted with one node instead of using two. If I used the restructured graph, I would have needed a configure primitive as well. Instancer, I mean, instancer works like the instancer in object level or very similar to, or like a copy to points. It uses all the things you already know, the attributes like p-scale or orient, up or normal, things like that. It's just that the original scene, you didn't use a lot of instancing. So this is very useful, and you can instance lights as well. So it won't really be an instance. You'll need to use references, but still you're copying lights on points with attributes, so you can orient them and everything. So that's very neat. And you'll end up using a LUP import a lot in those instancers. Just be careful not to point to a node that is downstream to the instancer, because you'll create a loop and it won't crash, but it just won't work. So just make sure that you're importing something outside from what's downstream of that node. All right, so what's next? We want to create a sequence and shot example. We want to convert all the material to material X, so you'll be able to use that scene with XPU. And eventually, we want to have a written tutorial to explain the process that we went through. And we're open to your ideas. If you think that there are some things we forgot about this and you have experience with USD and you'd like to share those ideas, we could adapt our scene before releasing it. Thank you to the marketing team and the original author of these scenes. So I did not create any pixel. I just used what was made and restructured things, but all their craftsmanship was really essential. So as we say, that's all, folks.
Hello. Thank you, LP. It's a little bit, I don't know, strange feeling, good and bad, like mixed feelings to see that bar scene again since Houdini 18. Because yeah, it's been a long time, but also we made a lot of developments and making, you know, small tools and nodes and everything to just make the, you know, it's not transition, but just ability to work with USD file format much easier than in 18. So you can see the results of that and you felt it.
And I'm not using the component builder at work, and really talking to Chris and how he developed it, I really considering using the component builder, maybe hack it a little bit, but there's a lot of good stuff in there.
Yeah, and you also gave him feedback. So, and that goes for everybody who is doing stuff, whether it's for LOPs, anything else in Houdini, you know, we always want to hear feedback and try to implement this stuff. But, you know, dev cycles, time, resources, all that. So we can't do everything at once. But yeah, we really appreciate your efforts in this and knowledge sharing. And we are also looking forward to all that content that you listed there. So.
Yeah, hopefully in the fall, we'll be able to release that.
So does anyone have any questions?
I thank you for the presentation. I was just unclear on one thing. How did you automate the component builder part? Like, how do you multiple assets go in there and go out?
Very good question. So talking to Chris, we sort of, did I skip the page? Let me circle through everything again. Yeah, this one. So that's what I said earlier, that the way I used the Python script was to create this LUP graph for every element that I found on disk, and they were renamed properly. But then I ended up going in there and creating every asset individually. I did not use PDG to process everything because I needed to author materials, change a few parameters, but with some expressions, I was able to, and you can see here at the top, I got a blank node, so that's just a null with some parameters there, and everything would be linked there. So I didn't want to create an HDA that would then be just open. So that's why I decided to go this way. But yeah, in the end, I needed to go through the 67 assets one by one and create the LUP graph. But anyway, in our studios, we end up authoring every asset one by one. So that's why I decided to go this way.
Awesome. Thanks so much.
Anyone else?
Hi. So I assume the purpose for this is mostly for training and sort of exploring. So one thing that I always find when looking at sort of Solaris things, there's always like, we'll show you a very simple way to set up something like a variant or something like that, and it's cup A, cup B, cup C, and then they're like, great, we explained it, and then you look at an asset from, say, like Animal Logic or something like that. They have like 14 variants that are all nested in like a lot of different ways. And I can see sort of a lot of things where it's like, okay, I see what they did, but there's not really an explanation of why we set this up this way. Or like in Component Builder, like I'll be like building an asset. I'll say, okay, maybe I want to try like a nested or a nested variant or something like that. Yeah. And I'll plug something in and it's like, oh no, can't really do that. And so it would be really great, when you do release this, to sort of maybe go through a little bit of like the mindset. Because I think what you did here with like explaining scopes and groups has been great. And that's something I've been, wrapping my head around. But I think there are other elements, that would be good to sort of understand, like, what's the thought process around the way these variants are assembled, or the way, things like that.
Yeah, and that's why we want to have those workshops and eventually the written tutorial. And I totally feel you. For example, the way we build our asset at Folks, we use subcomponents, and we end up having variants on those subcomponents and then asset components. But then those are two different levels, and I need to have a sort of curated list of valid combination of look and geometries, for example. Yeah. So I decided to keep it a little simpler here and just use the component builder as it is. But the way here materials are connected to the geometries, here you can see I got two input geometries. I can remember what the this asset is. Maybe it's the bar stool. Yeah, I think it's the bar stool. So I have two different geometries, and then I have four materials. But the way they're connected, only those three materials are valid with this geometry, and this one is valid with this one. So having those connections made properly will give you the proper combination. So when you have that asset or that component and you want to select one of the variant, it'll always match a valid geometry and material together. And that's some of the magic that makes me want to use a component builder at Folks.
Okay, yeah, I've been playing around with it myself, and some of the things that if you have variant switches, for instance, so if I had like a texture switch, the example we had was like a street sign, and we want to change the name of the street sign, but also we want to have a geometry variant that has changes the traffic light color, but also then we also want to put on a different traffic light, and then we also want to have on a walk sign. With the component builder is really hard. It's really easy to like set up one switch for each one of those, but to have those things sort of like be able to switch one thing independently of another, we're running into issues. So
right. So probably you'll want to, and I'm not entirely sure to understand, but I think you'll want to create a new variant set. And what happens is that what we struggle with our current asset structure at Folks is that when we have those components and subcomponents, and I want to have that created list of valid combinations, I need to make sure that my subcomponent variants have no default variant. So if I was to bring in the subcomponents by itself, it would load in empty in the viewport because there would be no default one, because that is the only way I would be able to have a top level variant set that would select multiple things that I chose as an artist. So maybe a way out would be to create a new variant set, and if that's not enough, maybe consider removing the default variant from the original set.
One last question, because they want us out of the room apparently.
Yeah, and I think.
Oh, is it drinking time?
Yeah, like in 7 minutes.
Joe doesn't want to ask now. Drinking, because he doesn't drink.
I just wanted to know if you had any advice or strategies for how you learned about USD, because I find the whole topic in general to be pretty tough.
I think we need support groups, man. No, but especially at events like this at SIGGRAPH, you would look at you would be attending a talk by larger companies that seem to have figured it out years ago. But I think I can remember who was saying that earlier today, but don't underestimate the time it takes. I think it was Animal Logic again that planned on transitioning within 18 months, but then it was Disney. Sorry. So it was Disney. They planned on transitioning into 18 months, but it took them 4 years. And honestly, at Folks, we were trying just on R&D assets, like would pull something from an archive project and just try to repackage it. And we just were in this limbo for a year. And then when we decided to say, let's try this sequence on that project with USD and Solaris, and whatever happens, we keep pushing. And I think in a month, we did what we did in a year, and then we just continued that way. I think it really depends on what render engine you end up using. Falling back to Karma, if you're not already using Karma, falling back to Karma really helps figuring out if you didn't understand something or if your render engine is currently not supporting what you're trying to do. But I think we just need to talk more between studios or between artists to figure out how we should organize our assets. And I think that demo scenes like this one, like I think a lab released a scene recently as well. So all of those examples would really be useful for the community.
And with that, we wrap it up for the day. Thanks, everyone. Thanks, LP.